In these examples, we want to find each sum or difference as indicated in the problems here. And before we start, I do want to mention that now we're dealing with complex numbers. You can see that in all of these examples, right, or at least the first two, it's pretty obvious that we have some values that don't have I attached at all. And then we have some expressions that do include I, and that means that we're dealing with complex numbers. Complex numbers have both a real part, the part without I, and an imaginary part, which includes the part with I. And so our answers should all be given in that complex number form, that standard form, which is in the form of A plus BI. So at number 3, we have the binomial or complex number 5 minus 3i plus the other complex number 2 plus 7i. Notice that we have the plus in between the two complex numbers, and so therefore what we're looking to do is simply to combine like terms. We don't have to distribute anything through parentheses here. So we're going to combine the real parts, which would be 5 plus 2 or 7. And we're going to combine the imaginary parts, which would mean negative 3i plus 7i, which would give you plus 4i, right? You combined those like terms just like you would if they were x's. It's just I has a very specific meaning. So our final simplified answer is 7 plus 4i. Number 4, we have the complex number negative 7 minus I radical 2 minus the complex number negative 7 plus 3i radical 2. So notice this time we have a minus sign between our complex numbers, which means we do have to distribute that through our parentheses. So we would end up with our terms here, negative 7, whoops, I tried to change that one, didn't want to, negative 7 minus I radical 2. And then negative times negative 7 when I distribute is positive 7. And negative times 3i radical 2 would be negative 3i radical 2. All right, so now let's combine our like terms. We can see that the real terms, the negative 7 and the positive 7 would cancel out. And then when we look to combine the negative I radical 2 and the negative 3i radical 2, we have to make sure our radicals still match. They're both radical 2's. And then the coefficients negative I and negative 3i are like terms. So we would combine those to get negative 4i radical 2. Or if you prefer to indicate that the real part is 0, you could say 0 minus 4i radical 2 as well. All right, and in this last example down here, number 5, notice that you don't see any i's, right? We see the real parts and we see radicals of negatives, which means the i's are hidden, right? So let's simplify this. Our first complex number, right, when we simplify this, I would keep the 7, okay, plus, right, notice that we've got that square root of a negative and 9 is a perfect square. So that means I'm going to get the square root of 9, which is 3, and the square root of negative 1, which is I. So 3i would be the term there. The negative underneath the radical does not change the sign out front. It just means that you have an I involved with your term. Okay, minus my second complex number. I'm going to keep the 3 minus 2 times, again, let's look at this radical. I have a negative, which means there's an I involved there because it's the square root. And then the square root of 25 is 5. So I'm going to end up multiplying that negative 2 times a 5i there. Plus, let's keep that 4 minus square root of negative means there's an I involved, and the square root of 4 is 2. So we're going to have a 2i there is what we're subtracting. All right, now with that, we can distribute any signs that we have in between our complex numbers, right? We have a minus there, we have a plus there, so we want to make sure that we distribute this subtraction that we have before that middle one here. So we would have 7 plus 3i minus 3, and then negative times negative is a positive. 2 times 5i would be 10i. Okay, and then keep the signs the same, plus 4 minus 2i. And now let's combine our like terms. Let's combine the real parts. So 7 minus 3 is 4, plus 4 is 8. And then plus 3i and plus 10i is 13i, minus 2i would be positive 11i. So we would get 8 plus 11i there is our final simplified complex number in standard form.